Hi, in this video we will find the derivatives of the trigonometric functions. We will start with sine and cosine, and then the rest will be just applying the differentiation rules. And you will see that the limit sine x over x as x approaches to 0 equal to 1 is going to play a very important role. Let us start with very simple differentiation question. So we want to find the derivative of sine x and cosine x at just 0. Basically check the differentiability, and if you can find the derivative. Okay, so you know that in general, if you want to find or check the differentiability of a function at a point at 0, you do f of 0 plus h minus f of 0 over h, and let h goes to 0. In this case, sine of 0 is 0, and we have a sine of h over h as limit of h goes to 0. And this is the limit that we studied before. And well, this means what? It means that if a function is sine x, the derivative at 0 is going to be equal to 1. How about the cosine function? So cosine of 0 plus h minus cosine of 0 over h as h approaches to 0. Well, cosine of 0 is 1, so what we get here is cosine of h minus 1 over h. When you get here, you notice that, we have 0 over 0. And for the trigonometric functions being in numerator or denominator, we don't have any technique than just using this limit here. So we want to kind of generate this sine box over box as box approaches to 0. There are different ways. For example, you can use double angle formula, or a simpler version will be, or simpler trick will be, you multiply numerator and denominator by the conjugate of that expression, the numerator. Why do we do this? Because you see, cosine h minus 1 times cosine h plus 1 will give us cosine squared of h minus 1 squared over h times cosine of h plus 1. Remember that 1 minus cosine squared of anything is equal to sine squared of that thing. So here in the numerator, what we have is, well, it's not sine squared of h, but negative of that. Okay? So this is limit of h was going to 0. Here also h goes to 0 of minus sine squared of h over h cosine h plus 1. Okay, so you see here that, well, there are cosine h and h in the denominator. We can put these two together. Yes. So I use one of the signs in the numerator and h in the denominator. And, well, the denominator, this piece of the denominator is good. This is limit of this guy's h goes to 0 is cosine of 0 plus 1, which is 1 over 2 in general. So I can separate that piece, limit of h goes to 0, and limit of 1 over cosine h plus 1 as h goes to 0. And also we can have, well, I already used one of these exponents, while the remaining one will be just one more sine h we have. as h goes to 0. Well, don't forget that negative sign. I will put it up front. This limit here, we know that it is 1, so negative of 1. This guy here is, well, cosine is continuous, and you get 1 over 1 plus 1. And sine of h, as h goes to 0, sine is continuous function, so you get sine of 0. Sine of 0 is 0, so everything will be 0. What we show was that, well, if f of x is cosine x, then the function is differentiable at 0, and the derivative is 0 for cosine. Very nice. Well, these were just derivatives at 0. How about general at point A? So the derivative, let me write it here, the derivative of f of x equals to sine of x at general point, yes? So what about this guy? Well, let's just check that. We are trying to find f prime at x. Then this needs to be found, x plus h minus f of x over h as h approaches to 0. And this guy, well, we know this is sine of x plus h minus sine of x over h. h goes to 0. Well, remember that, well, we have a formula for sine of a plus b, and this means that we can expand that one and write it here. So it will be sine of x times cosine of h plus, cosine of x times sine of h minus sine x over h. h goes to 0. Well, looking at this way, it's not a very clear limit what to do. But if you focus, you will notice that, well, these two terms have sine x. So I can factor out sine x from those guys and write the rest. So this is cosine of h minus 1 over h. Okay, so we took these 3 terms, and then h goes to 0, and plus limit of cosine of x sine of h over h as h goes to 0. Here what you have to notice is that the variable of the limit is h. This guy has no h. This guy has no h. So we can apply the constant multiple law, and you will see that this is h goes to 0, cosine of h minus 1 over h, plus, and that comes out cosine of x, limit of sine h over h as h goes to 0. And well, this is the derivative of cosine at 0, and we learned that this is 0, sine of x times 0, plus this limit is 1, so we have cosine of x times 1. So this gives us, well, the derivative of sine x. So let me just write as the first formula, the derivative of sine x is equal to cosine x. How about derivative of cosine x? Well, you can do same thing, same steps. Here you will end up having cosine of x plus h, and then you use the sum formula for cosine, and it will appear very similar to these guys. And you continue, and you can see that derivative of cosine x is minus sine x. So these are two first formulas for the derivative of trigonometric functions. And well, what is important at this stage is that every other trigonometric function can be written in terms of sine and cosine. For example, the derivative of tan. What is this guy? Okay, tan, we know it is sine x over cosine x. This is quotient of two functions, so we can apply the quotient rule. So derivative of sine x times cosine x minus sine x times derivative of cosine x over cosine x squared. Derivative of sine, we just learned this is cosine x minus sine x. Derivative of cosine is negative sine x over cosine squared x. Well, you do get this formula that cosine squared x, there's minus, there's another minus, you multiply, get plus sine squared x over cosine squared x. Now, you can do two ways. Simplify this guy in two ways. One is that, okay, you know that the numerator, sine squared x plus cosine squared x, is always equal to 1. And this is 1 over cosine squared x. But this is same thing as cosine x, 1 over cosine x to the power 2. But 1 over cosine x is secant squared x. Or what you can do, you can separate these guys and write them as cosine squared x over cosine squared x plus sine squared x over cosine squared x. And this gives us 1 plus, the other one is tan squared x. Both of them are equal, just different ways of writing the derivative. And that will give us the third formula, which is the derivative of tan x, which is equal to either secant squared x or 1 plus tan squared x. Well, I encourage you to do the derivatives of other trigonometric functions, and you will see that, for example, derivative of secant x is equal to secant x tan x. Or the derivative of cosecant x is minus cosecant x cotan x. And the derivative of cotan is minus cosecant squared x or minus 1 plus cotan squared x. So these are the rules that you have to add to your toolbox, the differentiation toolbox. Derivatives of all trig functions, sine and cosine up there, and then the rest are here. You have to work with these things so that you write them down without thinking of what is the formula. It should come up like that. Okay, so let's do some examples before we finish this video. Differentiate. Okay, very nice. I have this one. So start with f prime of t. So first derivative of this piece plus derivative of that. That's the sum rule, yes? Oops, derivative. Then we have a product of two functions. So it will be derivative of first one times a second one plus first one times derivative of the second one. And also for this one, we apply the product rule. And the result will be what derivative of t is 1 times sine t. That will be there. T derivative of sine t is cosine t. So this is cosine t. Derivative of e to the power t is e to the power t. And derivative of cosine t is negative sine t. You have to remember that negative sign. Well, you can go ahead, simplify a little bit more, but I'll stop here, just like that. How about this one? This is a quotient of two functions, so we have to apply the quotient rule. This is derivative of the numerator times a denominator minus the numerator itself times the derivative of the denominator, and then the denominator squared. This gives me derivative of tan is secant squared x, and you have this guy minus tan x. Derivative of x squared plus 2x, this is 2x plus 2. So we have that also there. Let's do this one. This is again another quotient rule. H prime of x is equal to derivative of numerator secant x prime times 1 plus tan x minus secant x numerator itself times the derivative of the denominator, and then the denominator squared. Very nice. And then we find all the pieces of the derivatives here. Secant x, the derivative of secant x is secant times tan. 1 plus tan x. This is a secant x. And then, derivative of 1 is 0. Derivative of tan is secant squared x. And then in the denominator, you have 1 plus tan x squared. Well, you can simplify the numerator, but I will leave it for you. You just go ahead. The worst is that you just expand everything, write everything in terms of sine and cosine, and then from there you can simplify everything. Very nice. Let's do this last one. We have a function y equal to e to the power x times secant x. We need to find an equation for the normal line. The point 0, 1. First thing to check is that 0, 1 point, note that when x is 0, then y will be 1. That means that 0, 1 is a point on the curve. So we will take that one as our point. We need a slope. Slope of normal line at 0 is equal to negative 1 over f prime at 0. Remember that derivative of tangent line is f prime at 0, but this is the normal line, so it will be negative 1 over that derivative. So we need to find what is f prime of x. This is product rule. This guy plus e to the power x is secant x prime. E to the power x is e to the power x is secant x plus e to the power x. Derivative of secant is secant x times tan x. You can simplify this. E to the power x is secant x. Factor that one and you get 1 plus tan x. Okay, at 0, f prime at 0 is now e to the power 0, secant of 0. Secant is 1 over cosine. 1 plus tan of 0. So that means what? That means that we have this is 1, this is 1, this is 0. So 1 will be the total. So then the slope will be negative 1 over 1. It is negative 1. We have a slope. We have point y minus y1 equals to m x minus x1. Y minus, you see this point, the second component is y1, the first component is x1. So here's y minus 1 equals to negative 1 times x minus 0. And that gives us y equals to minus x plus 1. That's the normal line to the curve at that point. So here, well, you have to remember these differentiation rules, add them to your new toolbox, and you have to be able to work with limits of same nature. So you have to be able to work a little bit, change some functions, and then simplify and so on.